Today I'm talking about my final year project. My final year project was stress level prediction using machine learning techniques. This was guided by Dr. G. Nalini Priyama, Associate Professor, Department of Information Technology, Savitha Engineering College. Let's get into the agenda. This is the agenda of my project presentation and directly get into our introduction. Introduction of my project is stress is becoming a significant global public health concern that affects millions of individuals. Long-term stress can be also harmful to one body and mental well-being, raising one risk of developing disease, including like diabetes, heart disease, and depressions. Thus, being able to precisely measure and forecast stress level may have a significant positive impact on health and disease prevention. And the statement of my project was the goal of this project is to develop a web-based application that can predict an individual stress level based on various input features. The application will leverage machine learning techniques to analyze the provided data and generate a stress level prediction. The predicted stress level can be categorized as low, moderate, and high. The input features are such as determine the specific input features that will be used for stress level prediction. The problem statement mentioned potentially features like demographic information, lifestyle factors, work-related factors, physiological data, physiological factor, environment factor, and all. So identifying the most relevant and accessible features of your application. And data collection acquired or recreated a labeled data set containing the input features and the corresponding stress levels such as low, high, and moderate. This data set will be used for training the machine learning model. And the scope of our project, the objective of stress level predictor website is to provide a platform for doctor to assess and monitor the stress level through a user-friendly interface. The primary goal is to assist user, including understanding their stress level and empower them to take protective measures to manage stress effectively. The website will serve as a tool for a doctor to cross-check the validate patient reported such as stress levels and facilitating the more accurate assessment and personalized treatment plans. And implementing a machine learning algorithm to analyze the user data and predict the stress level. The algorithm may take into the account various factors including lifestyles, emotional well-being, and external stressor. And the methodology of the product. First of all, we have to scrap the dataset from Python. Uh, Talking about using experience sampling techniques to periodically gather ground truth trust levels via surveys or mobile ecological assessment. Describe how this make it possible stress level addition to sensor data. I give an overview of how to use Python data science libraries such as like Pandas, NumPy, Scikit-learn with Jupyter Notebook for developing machine learning models. Describe the quick dataset exploration, data pre-processing, and analysis made possibly by notebooks. Next, data processing. Data processing in order to handle missing files, missing values, the raw time series physiological signals obtained from the sensors are cleaned and filtered to move artifacts. And to enable extraction of features at consistent intervals, statistical time domain features including mean, variance, and max and min are extracted various sensors modalities to obtain power distribution features across the very low, high frequency bands. To account for temporal context, addition aggregates are computed over multiple window duration. And next performance metrics. Performance metrics are critical performance metrics. The root mean square error calculates the residual standard deviation and a better fit indicated by lower values. The average magnitude of error in stress level prediction is calculated using mean absolute error. And R square shows how much of variation in stress levels the model can account for. And the accuracy determines the propagation of correctly predicted values for categories levels such as low, high, or better. Confusion matrix shows the model performance for each category of stress level, actual or predicted. And test and evaluation. Test and evaluation is the most important thing, whether the model correctly working or not. For this, Python manipulation is made easier by pandas. Data frames loading of the CSV files to determine the number of rows and columns, data types, summary statistics, and the value throughout the rows and columns. So the target value input futures columns are chosen for modeling from the data frame. So the Skylit learn encoders are used to convert the categorical data into the one-hot numeric representation. Data frame is divided into train and test sets. A robust model training is ensured by representative distribution through a random test train. So the transformed data frames with splits of target variable and encoded input features split the target variable to enable the creation and assessment of the data-driven stress level predictions. The series of procedures loads the data raw CSV files and gets it ready for machine learning use and divides into modeling sets. Architecture diagram for stress level prediction. First, data gathering and next data set importation. Data set importation is a main important thing to import the data sets into the program. And from this, we have to extract the extraction of features. We have to extract the feature that can be classified the stress level into the normal, low, or high or severe. And next, what are the algorithm we were used? We can see it here. Psychological time series data are used to train personalized deep neural network models and predict stress levels using supervised learning. We are using logistic regression. Regression is based on physiological input features. The probability of categorical stress level outputs, such as low, medium, high stress, can be modeled using linear classification or no algorithm known as logistic regression. In order to estimate class probabilities, it fits a sigmoid logistic function using methods similar to maximum likelihood estimation. And next, and we are used other also parameter hyperparameter optimization in as ensemble modeling, cloud-based implementation. Cloud-based implementation to speed up the training of deep learning models. A cloud compute instance TensorFlow GPU backend is used. And next, the requirements, functional requirements and non-functional requirements. Functional requirements are just seen before: data collection, data pre-processing, future extraction, machine learning models, and stress level prediction, and the user interface. Non-functional requirements are scalability, accuracy, security, robustness, and usability. Next, implementation of the code. Implementation of the code, we directly get into the code and the execution. These are the code segments we thoroughly see in the visual code and the output. These are the output interface. We practically see how it is working in Visual Studio working space. And it's the conclusion of the project. Stress level prediction using machine learning techniques. Project stands a valuable and innovative tool in the mental health assessment with a focus on empowering and supporting healthcare professionals. This project is mainly the capabilities of machine learning to predict the stress level accurately. The utilization of machine learning techniques has significantly enhanced the accuracy of stress level prediction. So, this user-friendly interface ensure is ease of use for the doctors, allowing them to engage in stress assessment seamlessly. So, this accessibility is a dedicated interface for doctors to cross-check and validate patients' reported stress level. This collaborative approach ensures the more comprehensive and accurate assessment. And also we have a future work of this project. The future work will be involved continuously collecting new user data and training the machine learning model periodically to improve accuracy, exploring advanced features such as engineering techniques, ensemble modeling approaches, and personalized prediction to tailor to individual user patterns. And also we have to integrate the wearable devices or sensors in future, providing a personalized stress management recommendation, identifying a stress triggers through root cause analysis, and incorporate to multimodal data sources like audio, text, images. Implementing explainable AI to interpret the prediction would enhance the website's capabilities. And these are the future work of our project, and it will impact in promoting stress level management practices across diverse user communities. Yeah, here we see how the project practically works. In here we have to import our libraries, and here importing our data sets, other next CSV file. And Next, about the data set, you will see the relationship between the parameters of snoring range of the user's respiration rate, body temperature, limb movement rate, blood oxygen level, eye movement, number of sleep hours, heart rate, and stress levels. It will show in the medium of low, normal, medium low, medium high, and high. So understanding our data and get into our column description. The column description such as SR means to snoring rate, RR means to respiration rate, and T is about body temperature of the users during sleep, and limb movement. Limb movement is the rate or intensity of limb movement during sleep, indicating how active or restless the person is. And BO is indicating blood oxygen level, which represents the amount of oxygen present in the blood during sleep. And REM is means to the eye movement activity during sleep, which might indicate the rapid eye movement phase of sleep. And SR1 sleeping hours, number of sleeping hours practically sleeping. And heart rate HR, the number of heartbeats per minute during sleeping, the essential physiological parameter related to overall health and sleep quality. And stress level, the target value representing the stress level during sleep categorized. Here now we get into the model training. Model training, first of all, using lot of classifiers. The first classifier is logistic regression classifier. Logistic regression, we are creating a logistic regression classifier object with the specified parameters. Using the logistic regression class from stylet learn, the max parameter is set into 1000, which determines the maximum number of iteration of convergence. And next we are the decision tree classifier, and next is a random forest classifier, and fourth is SVM classifier, and KNN classifier, and the last Gaussian naive uh, bias. These are the classifier we are using for stress prediction. Now we get into the Python main file. From here, from we have to import Flask. We're using Flask in this project, and import NumPy and Pandas. And from Skyden, we have to model selection metrics and linear models as importation of classifiers such as logistic regression. And now here, we in this case, when the post request is made, and now here we get the data from the input. We get the data from user input, the snoring rate, respiration rate, body temperature, limb movement, blood oxygen, eye movement, and sleeping hours, heart rate. These values are must to be in a float. Then only the it considers the input, and reading the CSV file and storing the data in the data frame called a dataset, and identifying the information about composition and the potential data quality. And we have renaming the columns of data frame for better readability and understandability. So and then we split the data into futures x and the target variable y. Here now then split the data into training and testing sets, such as 80% training and 20% testing. Now here create an instance of logistic regression model, uh, fit the model in the training data. So here, creating a new data frame for the user input. From the user input, we have to create the new data as a data frame. And predict the stress level for the new data. We have to predict the stress level for new data. And here there is a to map integer stress level to human readable labels. The human readable labels are such as known as low, normal, low, medium, high, and high, very high. And here get the human readable label for the predicted stress level, and we have to render the this HTML file and template the post prediction result to the display on the web page. Now here we have to run the project. Let's run. And we have to the app dot run function starts the Flask development server, and debug equal to true enables the debug mode. We have to enable this, and host 0.0.0.0 makes the app accessible for all network interfaces. So the link was provided. We just open it. Now yeah, this is a user interface page. We have to the enter the user input snoring rate as 78.9, and respiration rate as 98.0 and body temperature as 96.0, limb movement as 78.0, blood oxygen as 78.8, eye movement as 67.0, and sleeping hours as 7 hours 7.0, and heart rate as 98.0. Now we have to predict the results. The stress prediction shows as high. This indicates the high stress level prediction of in sleeping during sleeping. All the data from here we get into the project. So these are the prediction high stress prediction of this data entered in this interface. So thank you.